All right, let's be real. Have you ever been locked out of a critical research database, like right before a deadline? Or maybe you've just stared at some super cryptic error message on your university portal, totally confused. Yeah, if that sounds familiar, you are definitely not alone. So today, we're going to pull back the curtain on something called SAML. It's the tech that powers all those seamless logins, and by the end of this, you'll be a troubleshooting pro.
I mean, we've all been there, right? You click a button, you expect to get right into your app, and nope, you get hit with some bizarre error message. So what gives? Why does something that's supposed to be so simple sometimes fail so spectacularly?
Well, a lot of the time, the answer is hiding inside something called SAML, which stands for Security Assertion Markup Language. Think of it as the invisible engine that makes all that single sign-on stuff work. And in this explainer, we're going to decode the top 5 most common SAML errors. The goal? To take you from being totally stumped to being the person who actually knows how to solve the problem.
Okay, but before we can even think about fixing what's broken, we really need to get a handle on how it's supposed to work. So let's start with the absolute basics. What's the deal with SSO and SAML? Are they the same thing?
Here's the easiest way to think about it. Single sign-on, or SSO, that's the goal, right? It's that dream of having just one password to get into everything. Your university portal, all those research databases, you name it. SAML, on the other hand, is the technology that actually makes that dream happen. It's basically an open standard, a common language that lets all these different systems securely talk to each other and agree that, yep, you are who you say you are.
So when it's all working perfectly, what does that conversation between systems even look like? Let's walk through the normal SAML authentication flow, what we call the handshake. You can think of it like learning the steps to a dance. You have to know the moves before you can tell when someone's out of step. It's really a 4-step dance. So, step 1, you, the user, try to get into an app. We call this the service provider, or SP. Step 2, the SP doesn't know you, so it bounces you over to your organization's login page. That's the identity provider, or IDP. Step 3, you log in there, and the IDP creates this secure, digitally signed package of information about you, that's the SAML assertion, and sends it back to the app. And finally, step 4, the SP checks that package, sees it's legit, and boom, you're in.
Okay, so that's how it's supposed to work. But as we all know, it doesn't always go that smoothly. So now, let's get to the real meat of this. What goes wrong? Why does it go wrong? And, most importantly, what can you actually do about it?
All right, number 1. By far the most common problem you're going to run into is a missing attribute error. This basically means the application is waiting for some piece of info about you, say your first name or your email, and for whatever reason, the identity provider just isn't sending it. Or maybe it's sending it in a way the app doesn't understand. This is exactly the kind of thing that'll stop you cold when you're trying to log into a new e-learning platform for class.
Now, check this out, because this is where it gets kind of wild and shows you the real problem. The application, the service provider, might be asking for an attribute it calls first name. Simple enough. But the identity provider, let's say it's Azure in this case, it calls that exact same piece of information given name and uses this super long technical URL as its official name. It's the same data, just with a different label. And believe it or not, that tiny little mismatch is enough to make the whole login fail.
So, what's the takeaway here? It's all about precision. The fix is usually just diving into the configuration settings and making sure those names match up perfectly. And yes, that means they're case sensitive. Of course, there's also the chance the data is just missing. Like maybe your last name was never entered into your university profile. In that case, a quick update on the IDP side of things gets it all sorted out. Okay, error number 2. Signature validation error. Now, if we think of the SAML login as a digital handshake, this error is basically a broken handshake. It means the service provider got the information, but it has no way to trust that it's actually from the right place or that it hasn't been messed with along the way. This trust is all built on something called a digital certificate. The IDP signs the message with its private key, and the SP uses a public key to verify that signature. So you get this error if, say, the SP has the wrong public key, or if the certificate itself has expired. And here's a sneaky one. Sometimes a network firewall can actually alter the message just enough to break the signature without anyone realizing it. So the fix? You got to make sure those certificates match up and are current. This is super important, especially when you're protecting sensitive research data.
Up next, the dreaded 404, URL not found. We've all seen this one a million times on the web, and guess what? It's just as common in SAML. All it means is that after you logged in, the identity provider tried to send you back to the application, but it sent you to completely the wrong address.
And this is such a perfect example of how the tiniest details can wreck everything. The fix is almost always just a simple typo in the URL. It's officially called the Assertion Consumer Service, or ACS URL. We're talking a single wrong character, using HTTP when it should be HTTPS, or forgetting a slash at the end of the address. Any of those can send the whole thing into a dead end. Seriously, your best tool here is just carefully, meticulously proofreading that URL.
All right, our fourth common error is all about timing. See, a SAML assertion, a little package of your identity, it's kind of like a movie ticket that's only good for a very specific showtime. It's only valid for a really short window, maybe just a few minutes. And if it shows up at the application's door too late, the app will just reject it as expired.
Now, you might think this is because of a slow network, but usually it's not. The most common reason is way simpler. The clocks on the two different servers are out of sync. So if the IDP server thinks it's 10:01 and the SP server thinks it's 10:06, that 5-minute window of validity might already be gone before the message even arrives. The solution is pretty standard. You use something called Network Time Protocol, or NTP, to make sure all the servers have their clocks perfectly synchronized.
And finally, number 5. This one's a little different. It's a whole category of errors that are specific to a less common way of logging in, called IDP-initiated SSO. This is what happens when you start from, say, your main university dashboard and click a link to an app instead of going to the app's website first. Because you're starting from a different place, this flow has its own unique ways it can break. For instance, there's a parameter called relay state. You can think of it like a digital signpost that tells the application exactly which page to send you to after you've logged in. If that signpost is pointing to the wrong place, it'll fail. So the fix here is to first, make sure the app even supports this kind of login, and second, to double-check that all the settings, like that relay state signpost, are pointing to the right spot.
So, there you have it. 5 different errors that all look pretty different on the surface. But if you've been paying attention, you might have noticed a common thread running through all of them. What's the one surprising thing that causes almost all of these problems? It's this right here. This quote just nails it. The issue is rarely some super deep, complicated bug buried in the SAML protocol. Nope, it's almost always just a simple misconfiguration.
Think about it. It's a typo in a web address. It's a name that doesn't match because of a single capital letter. It's a certificate that someone just forgot to update. These are human errors, plain and simple. And the only way to solve them is with meticulous, almost obsessive attention to detail. Every single slash, every letter, every setting, it all matters. And that leaves us with a final question to think about, especially for those of you who are studying computer science or maybe building your own projects. Could a single misplaced slash or one capitalization error really compromise an entire enterprise login system? And the answer is absolutely yes. And that's the big takeaway. Understanding this stuff isn't just about fixing annoying login problems. It's about really grasping how fragile digital trust can be. It's about recognizing that when it comes to security, there is no such thing as a small mistake.